So what are our options when you look at measures of central tendency? Well, the one that we're mostly familiar with is the mean, and that one is simply taking all the scores, adding them together and dividing them by the number of scores. If you look at the number line, you can see why that makes sense. So if you were to take Penny's scores, 6, 8, 10, and 12, and you add them all together and divide them by 4, the result is 9. So that's what we had before, that Penny has an average score of 9. If you take Silver's scores, 4, 6, 8, and 10, add them all together and divide them by 4, you get an average score of 7. So that's great. Let's take the other example again. What if we then moved one of Penny's scores over to 1? Does Penny still do better than Silver? Well, the answer is yes. So even if you change Penny's score to 1, Silver stays with his average of 7, that's the mean. But if you add up 1, 8, 10, and 12 together and divide that by 4, you still end up with 7.75, which let's say is somewhere around here. So Penny is still doing a little bit better than Silver. In order for Penny to do worse than Silver, you'd have to move, let's say, this one over to 3. Now Penny has an average score of 6.5. So that's the mean, and that's how the mean can be helpful. This is the measure of central tendency that most people know and that most people are accustomed to. But there are times when the mean doesn't really work best, or it doesn't suit our purposes, and I'll give you one example. Let's say that instead of getting the 6, 8, 10, 12 score for Penny and the 4, 6, 8, 10 score, let's say that instead Penny got 3 8s, so she got 8, 8, 8, and then 1 12, and let's say that Silver got 3 10s, 10, 10, 10, and 1 4. Now who did better? Well, if you take the means, like you did before, and you were to add up all of Penny's scores and divide them by 4, you would get 9. If you were to add up all of Silver's scores and divide that by 4, you would get 8.5. So technically, Penny has done better. But look at that data, isn't that a bit weird? The idea that Penny's done better than Silver doesn't feel completely right when you look at most of Penny's scores being worse than Silver's and most of Silver's scores being better than Penny's. This shows us that a mean isn't always the best measure of central tendency. Sometimes, particularly if the data is skewed or clustered in funny ways, a mean can be misleading. Here, the means make it look like Penny's doing better and not Silver. But a different measure of central tendency, which is the mode, would make it look like Silver's doing better rather than Penny. Here, the mode is just the score that is repeated most often. The interesting thing about the mode is that it's not affected by extreme outliers, and that's what makes it very useful. For example, if Silver got a 1 instead of a 4, his mean would shift from 8.5 to 7.75. It would be a little bit lower. But his mode would not shift at all. So if we realign these, now our measures of central tendency are the mode, you see the real advantage of the mode. It doesn't matter what you do with the funny outliers, so if this one's 12, or if it's 15, or if it's negative whatever, or if it's 4, Penny's score remains exactly the same. As with the mean, you would still be able to say exactly how well they did, even if you had a mode. So you could say that Penny had a mode of 6 and Silver a mode of 10, or Penny a mode of 13 and Silver a mode of 4. They're still measures of central tendency and you can still compare them. They just function differently from the way the mean functions. The last one is the median, and I'll add another data point in order to make any sense of that. The median is quite simply the score that shows up in the middle of all the other scores. So it's the one that falls dead in the center. Here I've added 5 to make it a bit easier. So if you were to have Penny's scores here, her median would be 7, and Silver's scores, his median would be 8. And this would still be true even if Silver's other scores were shifted all the way down here, or if these scores were shifted all the way up. The median simply counts the one that falls in the middle. It doesn't matter how much you move anything else around, the one that falls in the middle is the median score. At the end of the day, whether you use the mean or the median or the mode Depends on what you're trying to do and what you think is fair. The useful thing to have is a measure. A single measure that allows you to stop looking at multiple data points and simply look at one and figure out whether or not one set is better than the other.